Hello and welcome to complex numbers and imaginary numbers. I think you're going to be very impressed with all that you understand after this lecture. I hope that you do. If you don't already know it, I feel like some of you already know it though. Okay, 1 second. Here we go. We have complex numbers, complex equations, and we begin it with the imaginary unit. So what are complex numbers? Complex numbers are what we use to solve linear equations when there was no way to take the square root of a negative number. Okay, so we've talked about how to solve linear equations. With linear equations, the variable x is raised to a single power, like 2x or 2x plus 1. They have one solution or they have no solutions, right? We've also talked about, so that was linear. Sorry, getting pen out. Linear. And I didn't even turn on a light. Is that better? Oh, odd. All right, so a linear equation will just have x raised to the power of 1, right? And then an exponential, or sorry, a quadratic equation will not be a straight line any longer, and the variable is raised to a second power, right? Here we can find two solutions. You can still find one solution. You might find no solutions, okay? So when we were using the quadratic formula, we stopped and said no solution when? When we got a negative number under the radical, right? There's no real way to take the square root of a negative number. The square root of negative 16 is not a real answer, even though the square root of 16 is 4, and negative 4 squared is a real number, right? To solve this problem, we use an imaginary unit. The imaginary unit is called I. It is kind of like when you have a problem and you don't know the number that you're looking for, and so you put in a letter in algebra, right? You put in x. The presence of the unknown number stops us, but if we represent the unknown number with a variable like x, then we can continue to work the problem until we know what x is, until we find the answer for x, right? Here, when you're stopped by a negative number under the radical, you can use the imaginary unit I to continue working until the problem is solved. The imaginary unit I is equal to the square root of negative 1. So I squared, it follows, is equal to negative 1. When you work with complex numbers, that's what you need to know. The imaginary unit grouped with a real number is called a complex number. If you only have the imaginary part, you can still call it a complex number. If you only have the real part, you can still call it a complex number. The real part is the A. It does not have an I with it. The imaginary part is the BI because it has the I with it. You should always write it as A plus BI. So if you have a combination of 6I and 4, 4 should always be in front of the 6I. Good. You can add them, you can subtract them, you can multiply them, you can divide them, we can even graph them, okay? So basically, you're going to be able to continue problems which you thought you had to stop because of a negative under the radical. To combine complex numbers, combine the real parts and the imaginary parts, just like we're combining like terms. So treat I a bit like other variables, except that if possible, if you ever get I squared, you can convert it to negative 1 and continue working the problem, okay? So in this sense, we're just combining like terms. Here we have a 4. We're going to be able to combine it with a negative 1. And we have a 6i. And we're going to be able to combine it with a 2i. Good? So 4 minus 1 plus 6i, and 2i. Just like when combining other like terms, make sure you are careful of your signs. 4 minus 1 becomes 3. 6 and 2 become 8. So the complex numbers 4 plus 6i and negative 1 plus 2i become 3 plus 8i. Good. Here, though, we are subtracting, so we're going to distribute the negative or the minus sign. So we have 4 plus 6i minus negative 1. So minus negative becomes a plus 1, minus a positive becomes a minus 2i. So I distributed that negative sign. Minus a negative 1 becomes a positive 1, minus a positive 2 becomes a negative 2. Said it again just for my own sake because I often make mistakes. 4 and 1 and 6 minus 2. So I'm combining the like terms. We have the real parts, 4 and 1, and we have the imaginary parts, 6 and negative 2. 4 and 1 become 5. 6 and negative 2 become 4i. If you want to multiply complex numbers, you just use the distributive property. Always leave the answer in a plus bi form because that's the standard form. Real number in the front, imaginary number in the back. So remember that I times I becomes I squared. And what does I squared become? Negative 1. Because I is the square root of negative 1. If I take the square root of negative 1 and square it, I just get negative 1. Got it? When you are multiplying the i's, you treat them just like you're treating a variable x. I to the first power times I to the first power. You can use the rules for exponents, which is when you are multiplying exponents, keep the base and add the exponents, right? So 2 times 2 becomes 4. And then I times I becomes 4i squared. And then we're going to take I squared and we're going to substitute it for a negative 1. Negative 1 times 4, which is negative 4. You don't need the parentheses. Next one is 6 plus 5i times 3 plus 7i. So I hope what you think is, this is a binomial. I'm going to FOIL it. 6 plus 5i times 3 plus 7i. We're just going to FOIL it. 6 times 3 is 18. 6 times 7 is 42i, because the 7 had an I for inside, not I for imaginary number. 3 times 5 is 15 with an I, because the 5 had an I. And then the L is 5 times 7 is 35. But then I times I is I squared, just like over here it was I squared. They are all positives. So after I FOIL them, it was at positive 18, positive 42, positive 15, positive 35, I squared. Sorry, I stopped saying the i's. All right, let's look at it. 18, 42, and 15 together gives us 57. So I'm just combining the i's. There are 42 of them and 15 of them, so they become 57. 35, but remember what we do with I squared? We change it to a negative 1. So we're going to take that 35, multiply it by negative 1, and we have 18 minus 35. I move them together, plus 57i. Okay, 18 minus 35, negative 17. Negative 17 plus 57i. Good? You're just pretending it's a variable, you're following the rules of a variable, but if at any time you get I squared, you replace it with a negative 1. Okay, we've added them, we've subtracted them, we've multiplied them. Let's distribute this 3i to the -2 and the 5i. So 3i times a -2 plus 3i times a 5i. 3 times a -2 becomes a -6i. 3i times 5i, 3 times 5 is 15. I times I is I squared. Remember, anytime you have an I squared, you must change it to a -1. So now we're multiplying 15 times a -1, so we get -6i minus 15. However, it needs to be in A plus BI format, so it's -15 minus 6i for that final answer. Good? All right. If A plus BI is a complex number, then you need a complex conjugate. Why? Because you might encounter a rational expression with an I in the denominator. Okay? When you have an I in the denominator, you must remove it, just like we have to remove radicals from the denominator. It's known as rationalizing the denominator. Okay? You can't leave a radical in the denominator. It is improper. You can't leave an imaginary unit in the denominator either. Okay? So, for number 1, we have 3 plus 2i divided by I. What do I want to do? I want to get rid of the I, right? There's an I in the bottom. If I multiply it by I can just change it to a -1, right? Because I times I will be I squared. I squared will become -1. The i's will go away. So I'm going to multiply the bottom by I. I'm going to multiply the top by I, because if I'm multiplying a fraction by a term that is the same on the top and the bottom, it's just multiplying that fraction by 1. Anything times 1 is itself. So that becomes 3 plus 2i times I over I times I. Okay? Distribute that I, we get 3i plus 2i squared over I squared. Now I'm going to switch those I squares for -1s. 3i plus 2 times -1 over -1. Now I have -2 plus 3i divided by -1. Distribute that -1. -2 divided by -1 plus 3i divided by -1. Negative times a negative divided by negative is a positive, so that becomes 2. Positive divided by negative becomes a negative. So my final answer to 2 plus 3i divided by I is 2 minus 3i. Okay? Here I have 2 minus 5i divided by 3i. I'm going to do the same. I'm not worried about that 3. I'm just going to multiply the top and the bottom by I. So that becomes I times 2 minus 5i divided by 3i times I. So there's that I put that one in front just to distribute it, and I left that one behind because it was just in the back. I times 2i is 2i. I times a -5i is -5i squared. 3i squared. 2i minus 5 times a -1 divided by 3 times a -1 will be 2i plus 5 over -3. Good. -2/3 I minus 5/3. Sorry, it wouldn't be that. It would be -5/3 minus 2/3 I, because I said put it in A plus B format. A plus BI format, or you can just say it's -5 minus 2i over 3. You can put them on as two fractions or as one fraction, either way. So that's how to do the first two. However, I know I skipped this explanation because I wanted to show you that we are removing I from the denominator. This is how we do it. However, if we have 1 minus I, we need to use the complex conjugate of that term, okay? So if a plus bi is a complex number, then the conjugate is a minus bi. The only thing that we change is it's a plus bi, so the conjugate is a minus bi. If it is a minus bi, the conjugate is a plus bi. Good? The reason we use a conjugate is because when you FOIL it, you'll get a real number, this and this will cancel, and this will become a real number, so your answer will be a real number. The product of the complex number 2 plus 5i and its conjugate. What does that mean? Yeah, it's the same binomial, so the same binomial of 2 and 5i, but there's an opposite sign between the two binomials. If it was 3 minus 7i, the complex conjugate would be 3 plus 7i, right? If it's 2 plus 5i, the complex conjugate is going to be 2 minus 5i. So you can either think of it as the same terms with a different sign between them, or I just make the second term negative, but make sure it's in the correct order. Make sure your bi is behind your a before you make it a complex, before you conjugate it. Okay, it won't work if you have 5i minus 2, 5i plus 2. That will not work. And when we say real number, it's just a number you can find on the number line, right? 5i is not on the number line, but 5 is on the number line. So find the product, means multiply, of the complex number 2 plus 5i and its conjugate. 2 plus 5i, product means multiply. Its conjugate is 2 minus 5i because those are the same terms, 2, 2, 5i, 5i, different sign between them. 2 times 2 becomes 4. 2 times a negative 5i becomes negative 10i. Positive 5 times 2, sorry, positive 5i times 2 is a positive 10i. And then positive 5 times a negative 5 is a negative 25. But an I times an I is an I squared. Okay, so now I have 4, negative 10i and positive 10i cancel. That's why we did it. Minus 25i squared. Minus 25, and what do we do with I squared? We change it to a negative 1. So now we have 4 minus 25 times negative 1, 4 plus 25, because negative 25 times a negative 1 is a positive 25, so that's 29. Good? You are going to get rid of the denominator here by doing this. So I had something that looked very complicated. By multiplying it by its conjugate, I just got one real number. So here, the conjugate of 1 minus I is going to be 1 plus I, and I do it to the top and the bottom. Okay? So 2 plus 3i over 1 minus I was our original equation, or it's not an equation because it doesn't have an equal sign. And I'm going to multiply the top and the bottom by the conjugate. 1 plus I, 1 plus I. FOIL it. 2 times 1 is 2. Sorry, confusing. 2 times 1 is 2. 2 times I is 2i. 3i times 1 is 3i. 3i times I, 3i squared. You're probably like, what? That doesn't cancel. It's okay if it doesn't cancel on the top. We just wanted it to cancel on the bottom. Okay? So on the bottom, we have 1 times 1 is 1. We have 1 times I is I. We have negative I times 1 is negative I. And then our last term was negative I times positive I, so that's negative I squared. 2. Positive 2i plus 3i is 5i. 3 times I squared is 3 times a negative 1. 1. I and negative I cancel, minus I squared, which is a negative 1. Good. So now we have 2 minus 3, right? Because 3 times a negative 1 is a negative 3, plus 5i, divided by 1 minus a negative 1, or 1 plus 1, which is 2. 2 minus 3 is a negative 1. So I've got negative 1 plus 5i divided by 2 as my final answer. There is no I in my denominator anymore. All right, so for these next 3 examples, we are just taking a negative under an even root and we're translating it to a complex number. So the square root of negative 1 is I. Done. The square root of negative 25 is the square root of negative 1 and positive 25. The square root of negative 1 is I, and the square root of 25 is 5. The square root of negative 12 becomes the square root of 12 times the square root of negative 1. The square root of negative 1 becomes I, right? 12. Are there any perfect squares that go into 12? Yes, 4, right? So we still have I square root 4 times 3. The 4 comes out as a 2. So it's 2i square root 3. Just like square root of 12 would be 2 square root of 3. Negative square root of 12 would be 2i square root of 3. That's the difference. So you're doing the exact same factoring we did in the previous unit on, or previous lesson on radicals. But if you have a negative, you can move the negative out as an I outside the radical. All right, let's solve each equation. And these were previously unsolvable, right? We would stop because we would take the square root of a number, of a negative number here, and we would have no solution, right? X squared equals 16. Got ahead of myself. That's not even a negative. What do we do to get rid of the x squared? We take the square root. The square root of x squared is x. The square root of 16, we have to remember to put the positive and the negative in front of it. So we have the square root of 16 is 4. X is a positive 4 or x is a negative 4. X is negative 4 and 4 as our 2 answers. Here we have x squared equals negative 25. Good. Take the square root, take the square root. We're going to do positive and negative still, okay? The square root of x squared just leaves us with x. The square root of negative 25 is 5i, right? We decided that. And it's positive 5i and negative 5i. So x is negative 5i, 5i. All right. Last one. X squared minus 2x plus 5 is 0. Now, if I was to factor this, right, I know there's nothing that will multiply to equal positive 5 and also add to equal a negative 2, right? Because the only factors of 5 are 5 and 1. And 5 and 1 don't add to a negative 2. Negative 1 and negative 5 don't add to a negative 2. So what I want to do is use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2a, right? So let's just substitute those in. X equals, b is negative 2, so negative 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times 1 times 5 over 2 times 1. Negative 2 is a positive 2, plus or minus. Negative 2 squared is 4. 4 minus 20, right? Because 4 times 5 is 20. Over 2 times 1 is 2. 2 plus or minus the square root of negative 16 over 2. Yeah? The square root of negative 16 is 4i. Here, you can reduce 2 divided by 2 is 1, 4 divided by 2 is 2. So I'm going to say x is 1 plus or minus 2i, because 2 divided by 2 is 1, 4 divided by 2 is 2. So our final answer is x is 1 minus 2i. X is 1 plus 2i. So things that we formerly could not finish solving, we can now finish solving through imaginary numbers and complex solutions. Complex number solutions. All right, the discriminant, if you notice, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. The discriminant is everything that was under that radical, b squared minus 4ac, right? It's part of the quadratic formula, and it used to be that without, if this was a negative number, we would say no solution or an imaginary solution. If this is 0, we only have one solution because the plus or minus goes away. And if this is a positive number, then we have two solutions because we have this number added to this number or this number subtracted. Sorry, this number subtracted from this number. The discriminant tells you how many solutions you have. You either have two real solutions because the number under here is positive. You have one real solution because it's a 0 and it cancels out, or you have two imaginary solutions or complex solutions because it's a negative number, okay? So just using what you know about the quadratic formula and what you now know is called the discriminant, without solving, tell me whether the equation has two real solutions, one real solution, or two imaginary solutions, okay? A is 2, B is negative 4, C is 1. Do you see what I did? So I'm putting it into the quadratic formula, but I'm not doing the whole quadratic formula. I'm ignoring the negative b plus or minus 2a. I'm just using the part under the radical. I'm not even using the radical. So I just need b squared minus 4ac. B squared, in this case, would be negative 4 squared minus 4 times a times c. Negative 4 squared is 16. 4 times 2 is 8, times 1 is 8. 16 minus 8 is 8. So that is two real solutions. Okay. All right, I wanted to quickly look at my math lab and make sure I'm using the right terminology. So your three choices are two real number solutions, two unequal real number solutions, one repeated, they say, one repeated real number solution, real number solution, and two complex conjugate solutions. So those two make sense. That one's the same. All right, so this one would be two real solutions. Next one, same exact thing. So we have what is A, what is B, and what is C. It's already in standard form. So A is 1, B is negative 2, and C is 6. B squared minus 4AC. Negative 2 squared minus 4 times A times C. What do we think? Negative 2 squared is 4, minus 4 times 6 is already really big, right? 24. So that's a negative number. It's just negative 20. So if it's less than 0, it has two complex conjugate solutions. I would say that is this situation. This is two complex conjugate solutions. Finally, we are looking at A is 4, B is 12, C is 9. Good. B squared is going to be 12 squared minus 4 times A times C. 12 squared is 144. 4 times 4 times 9. 144. 144 minus 144 is 0. So that's one repeated solution. Good. So that's the discriminant, and that is all for today. Thanks so much and have a good one.